So we're going to go through a couple of examples of these problems that are really common in pre-calc and any trig class. You're being asked to find all 6 trig ratios. That's the sine, cosine, tangent, cosecant, secant, and cotangent of some angle. If all we know is that the sine of the angle is negative 2/3 and the cosine of the angle is greater than 0. So what they've done is they've given us 2 clues about this angle. And what we need to do is kind of suck up all the knowledge that we have about this stuff to come up with the answer to be able to figure out what the other 4 or what the other 5 trig ratios are, because we already know the sine, they told it to us. So we need to find the cosine and the tangent, and then once we have those 2, the other 3 are easy because all we have to do is flip the fractions, because the other 3 are the reciprocals. So the major thing I like students to know about these guys is that the sine of the angle is always having to do with the y coordinate, the y value, how tall the triangle is going to be. And the cosine of the angle is always about how wide it's going to be. It's going to be about the x coordinate. So I would say sine goes with y, cosine goes with x. Sine goes with y, cosine goes with x. So what we have here is a situation where the sine of the angle is negative. And if you think about the sine kind of telling us about y, and that being negative, you just think about on a coordinate plane, where are your y values negative? Well, your y values are negative down here. So that means our angle must be somewhere either in the bottom in quadrant 3 or 4. The other hint that we have is that the cosine goes with x, and they've told us that the cosine of this angle, a little bit confusing because the angle is called x, not to be confused with like the x-axis. It's just the missing angle, so they used x. The cosine of the angle is greater than 0. Well, the cosine goes with the x values. And if the x values are greater than 0, that means we need to be over here where the positive x values are. So that means we need to be on the right side, either in this quadrant or in this quadrant. And every time you do one of these problems, what's going to happen is between the 2 clues, you're going to have one quadrant that satisfies both conditions. We need the sine to be negative, which means we're in the bottom, but the cosine to be positive, which means we're on the right, which means we've got to be in the bottom right. So our angle is going to be in the 4th quadrant. So now all you do is you start at the origin and you draw a diagonal line out into that quadrant. Doesn't matter how you draw it, anywhere out there. Then bring a perpendicular back to the x-axis. Always, 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 always go back to the x-axis. Never come over the y-axis. Come back to the x-axis. And you might want to put a little thing in here to remind us that that's the reference angle that we're going to be focusing on. I probably shouldn't put a theta there. I should put an x because our angle is called x. But there's the triangle we're going to be focusing on. And as soon as we label it, based on the clues we have here, that the sine is negative 2/3, which is, if you remember your SOHCAHTOA, sine is opposite over the hypotenuse. We're going to put a negative 2 for the opposite side there, and we're going to put a 3 for the hypotenuse there. And we are most of the way home on this problem now. A little quick note for this is kind of a basic example. I'm going to do one that's a little bit more complicated as a second example, but as far as the positive negative stuff goes, it really doesn't matter if that negative sign is in the top or in the bottom or out in front. It means the fraction is negative. Here's one thing for sure though. Whenever you're drawing these diagrams, no matter what quadrant you go to, the hypotenuse is always going to be a positive quantity. The hypotenuse is always positive. The hypotenuse is always positive. The hypotenuse is always positive. X's could be positive over here and negative over there. Y's will be positive in the top and negative in the bottom, but the hypotenuse is always positive. Lastly, the only thing we need to do now is figure out what is this missing side up here. And as soon as we have that, we're going to have all 3 sides of the triangle. We'll be good to go. So we just need to do a little Pythag on that. So I'm going to put a question mark there because we don't know how long that side is. And we just have to remember Pythag that says a squared plus b squared equals c squared. So I'm going to say question mark squared plus negative 2 squared equals 3 squared. So question mark squared plus 4 equals 9. Subtract 4 from both sides. Question mark squared equals 5. We take square roots of both sides. And we say question mark. Now, this could be either positive or negative root 5. And we don't have to guess because we can see that it's over here on the right side. So if you're going over to the right on the x-axis, it's got to be positive. So I'm going to put a little, maybe scratch out our question mark there and put a positive root 5 there. So our triangle kind of looks like this, where we've got a 3 here, a negative 2 here, and a positive root 5 there. There's our angle. And all we need now is little SOHCAHTOA. So we already know the sine is negative 2 over 3. So we look at the sine as negative 2 over the hypotenuse. So the opposite over the hypotenuse. Got that one. So let's grab the other ratios. The cosine of our angle x in here is the adjacent over the hypotenuse. So the adjacent side is the side that's next to it, that's not the hypotenuse. So that's root 5 over 3. Adjacent, oops, I said root 3 over 3. Root 5 over 3. The tangent is the opposite side over the adjacent. So I'm going to put negative 2 over root 5. And your teacher would probably prefer if you didn't have radicals in the bottom, so we're going to multiply by root 5 over root 5. So negative 2 root 5 all over 5. And now the hard part's done, because remember, we already knew that the sine of our angle is negative 2/3. So for the reciprocals of all these, we don't have to do any work. We just have to flip these fractions. The reciprocal of cosine is the secant of an angle. So that's going to be this guy flipped upside down. So it's going to be 3 over root 5, which is going to turn out to be 3 root 5 over 5 when you fix the denom. The tangent is negative 2 root 5 over 5, but it might be easier to focus on this version of the tangent, because once we flip it to make the cotangent of our angle, if we just flip this guy, we're going to have root 5 over negative 2. And notice that we don't have to worry about fixing the denominator, because the denominator went up to the numerator. And lastly, the reciprocal of sine is the cosecant. And we can flip this fraction over here and just turn that into negative 3/2. Okay, so there's I would say a little bit of a basic example for one of these guys. And I want to kind of turn the page now and do one that's maybe a little bit more complicated. All right, so we've got a little bit more of a complicated one here. This is about as bad as these guys get. So we have information that the cotangent of our angle is negative 3/4. You'll see I called my angle theta this time, so we didn't have that confusion. The cotangent is negative 3/4, and the secant is negative. So we're going to start the same way we do all these problems. I'm going to draw a quick little coordinate plane here just to kind of keep track of our information. And again, I talked a lot about how sine goes with y and cosine goes with x. So what we have to remember is that the cotangent is the cosine of an angle over the sine. You really need to know those reciprocal identities, just the ones that are most basic, like secant is reciprocal of cosine, cosecant is reciprocal of sine, tangent is sine over cosine, and cotangent is cosine over sine. Now, we know that this cotangent is negative. Okay, they told us that it's negative 3/4. So I'm going to say, that is less than 0. It's negative, however you want to think about that. And what that really means fraction-wise is the only way you're going to get a negative is if the top and the bottom have opposite signs. One of them's positive and one of them's negative. But the thing is, we don't really know which one's which. You might think, teacher put the negative sign up there, so it's got to be the cosine that's negative. Well, if I write a fraction as 3 over negative 4, it's exactly the same as negative 3 over 4, which is exactly the same as negative in the front, 3 over 4. We don't really know where that negative sign really belongs. And teachers can kind of intentionally trick you up with that to make sure you know what you're doing. So here's what we're going to do. We're just going to say that we know that the cosine and the sine have opposite signs. One's positive, one's negative. This is going to be the guy that's going to help us figure it out. We know that the secant is negative, and the secant is 1 over the cosine. So if the 1 over the cosine turns out to be a negative number, well, we've got a 1 in the top and we've got a question mark in the bottom, and we know the answer turns out to be negative, it's got to be this guy that's negative down in the bottom. So that kind of tells us if the secant's negative, the cosine is negative. Okay, so the cosine is less than 0, cosine is negative. So just like we did last time, if you think about the cosine being related to the x value, and that thing is negative, you got to think, okay, well, where are my cosines negative? Cosine goes with x, so that's left and right, it's over here. And where are the x's negative? They're over here. So that means our angle has to be on the left side, either here or here. And now we're going to use our other clue that we knew that the cotangent was cosine over sine. Well, we just found out that the cosine, the top, was negative. And the bottom, the sine, we don't know, but we know the answer turns out to be negative. So if you have a negative divided by something and the answer turns out to be negative, this guy down here has got to be positive, because that's what happens if you multiply, or I'm sorry, if you take a negative divided by a positive, you're going to get a negative answer. This can't be negative down here because you'd have a negative divided by a negative, which would be positive. So we now know that the sine must be positive. So the sine is positive. Remember, the sine goes with your y coordinate. And if your y coordinates are positive, we're talking about the y coordinates here. The y coordinate's positive, you've got to be up here. So our angle must be in the top. This rate, either the first quadrant or the second quadrant. Once again, just like last time, you see one of the quadrants meets both conditions. So our angle's got to be in that quadrant. Since I've butchered that picture a little bit, I'm going to start fresh down here and say I know my angle goes off in the second quadrant. And I know that I'm going to drop my perpendicular back to the x-axis. Mentioned that on the last problem too, that we always take, after you go out from the origin to whatever quadrant you're going to, you always go back to the x-axis to form your angle. So if I was down here, I would come up here. If I was down here, I'd come up here. If I was up here, I'd come down there. I can label the angle in there as theta. And one more time, we go back to SOHCAHTOA, and we can think about the tangent, which is opposite over adjacent. That means the cotangent would be the adjacent over the opposite. So with our cotangent being negative 3 over 4, we know the adjacent side must be 3 and the opposite side must be 4. So the adjacent side must be 3, the opposite side must be 4, and don't move away from this thing until you decide which one of these numbers deserves a negative sign. I went left here, so going left on the x-axis means that guy's the one that should have the negative sign. Also, you should note that we went up on the y-axis, so that guy should be positive, which he already is. And you'll probably recognize that we need to do some Pythag to get this last side over here to get the hypotenuse. But I think most people know that when you have two sides that are 3 and 4, the third side is going to turn out to be 5. 3, 4, 5 triangle. But if not, just do Pythag to get it. And remember, like I mentioned in the last problem, the hypotenuse is always positive. The hypotenuse is always positive. So that side is always going to be positive. And now it's going to be real easy to find all 6 trig ratios. We already know that the cotangent is negative 3/4. All right, so we put a negative 3/4 there. That means its reciprocal, the tangent, is going to be 4 over negative 3, or negative 4/3. We need the sine, and we need the cosine. As soon as we get those, we'll know what the secant, cosine's reciprocal, is, and the cosecant, the sine's reciprocal. So the cosine, we go and look at our angle. Here it is. Cosine is adjacent over hypotenuse, so it's negative 3 over 5. The secant just flips that, 5 over 3 with a negative sign out in front. The sine is the opposite over the hypotenuse, so 4 over 5, and the cosecant is 5/4. So there you go. There's two, the first example is fairly straightforward. The second one, determining this quadrant, outside of just memorizing a whole bunch of stuff, which is one way to do this stuff, just memorize where the quadrants are positive and negative and all that stuff. I think this reasoning about the cosine being x and the sine being y kind of is universal, and it works for everything. So hopefully that'll help out.